Welcome to YUGAS Academy. So today we are going to discuss one of the most important topic for the prelims 2026, that is earthquake. See, earthquake is one of the important topic for prelims as well as mains. So this, see, every year you will see the news with respect to earthquakes and tsunamis and landslides, all these things and all. See, earthquake is something, it has multiple chain effect. See, it has multiple chain effect. Earthquake triggers tsunami. Earthquake triggers landslides. Earthquake triggers volcanoes. So, see, there are multiple factors which are initiated by the seismic activities, that is earthquakes. So this year there is a earthquake with respect to India, with respect to Russia, with respect to Japan. See, every year you will get a earthquake news with respect to Japan. So let us go to the current affairs. So Delhi experienced 4.0 magnitude earthquake, making the strongest earthquake since 2007. The shallow depth of the earthquake resulted in significant tremors felt across the national capital region. See, this is not new. Every month, the Delhi national capital region experience tremors. So the government of Japan, here why this year this is important means the government of Japan released the forecast report warning the potential magnitude 9 megaquakes. See, it is not earthquake, it is megaquakes. When the when the Richter scale passes more than 8.0, it is called megaquakes. So let us discuss all these things in this video. So the government of Japan releases a forecast report warning the potential magnitude 9 megaquakes within next 30 years, particularly along with Nankai Trough. The Google and University of California Berkeley Seismology Laboratory have released the performance data Android earthquake alert system. See, here the first UPSC will ask the question. Android earthquake alert system is released by Google, University of California Berkeley Seismology Laboratory. So the detailed performance data on earthquake. In July 2025, one of the strongest earthquake recorded in measuring 8.8 magnitude struck the Kamchatka Peninsula in Russia far east. See, Russia's peninsula, Kamchatka Peninsula, has experienced 8.8 magnitude of mega earthquake. Say earthquake, it is one of the deadliest earthquake, one of the strongest earthquake recorded in the history of earthquakes. Taliban spokesperson Zabullah Mujahid confirmed that. So he also felt earthquake of magnitude of 6.0. So in his areas, see, that means the earthquake has been hit multiple areas. So let us see the some of the facts regarding earthquake. See, earthquake is a shaking or trembling of earth's surface caused by seismic waves. See, seismic waves are earthquake waves. So it is see, you most of the people know it is due to the earthquake originated at the interior of the earth due to plate movements, and that is the energy releasing. The earthquake is a mechanism of releasing of energy on the surface of the earth. So earthquake is generally due to sudden movement of earth crust. See, when the earth crust moves, it is called shallow focus earthquakes. When the earthquake caused by upper mantle movement, it is called a deep focus earthquake. So now let us come to the important point for the exam. The point where the energy is released is called focus. Where the energy is released on the surface of the earth. So on the interior of the earth, on the interior of the earth, where the energy is released is called as focus or hypocenter. Focus or hypocenter. The point on the surface directly above is called epicenter. See, the point where directly above the point on the surface of the earth where the energy is released is called epicenter. So now this energy will be released in multiple areas. So now you connecting all points of similar intensity is called as isosesmal lines. Intensity is a measurement of earthquake. So seismic activities, ground shaking, tsunami risk, earthquake alerts. See, these are all impacts of the earthquake. Okay, now let us come to the another important point. See, waves. There are several different kinds of seismic waves. They all move in different waves. Two main waves are body waves and surface wave. Body wave can travel through Earth's interior layer, but surface wave can only move along the surface. Surface, the name suggests, it is surface. Body wave, it is only interior, it is interior. Now the body wave is divided into two types. One is P wave and is S wave. The P wave is name suggests it is primary wave, S wave is secondary wave. The first kind of body wave is P wave. It's called primary wave. See, the first kind, when the earthquake, the first kind of body wave is called P wave. It is called primary wave. See, it is a first wave arises when the earthquake earthquake originates. It happens. This is a fastest. See, let us have a comparison study over P wave and S wave, because UPSC asked the question over these areas. The first kind of body wave is P wave. See, body wave is P wave. The second type of body wave is S wave, secondary wave, which is second wave felt in the earthquake. So this is first wave. P wave is first wave. This is fastest seismic wave, and consequently first to arrive. P wave is first to arrive. S wave is second to arrive. So the P wave can move only can move through sorry. P wave can move through solid and fluid. See, UPSC PYQ. So it is P wave can move through solid and fluid. Solid and fluid. S wave is slower than P wave. Can only move through solid. But P wave can move through solid and liquid. But S wave can only through solid. S for only solid. So if P wave is fastest wave, first to arrive. S wave is second to arrive. S second. P fast, first to arrive. So it is a property of S wave that seismology is conducted that in Earth's outer core is liquid. With the help of S wave only, we just found out that Earth's outer core is liquid. So because it is S wave, S wave does not pass through liquid. S wave moves rock particle up and down, up and down, up and down. So and side to side, perpendicular. So the direction where the traveling. See, the PS waves move up and down. It pushes and pulls. It pushes and pulls. It pushes. That means compression and tension, compression and tension, compression and tension. So it is up and down, up and down. So this is difference between P wave and S wave. This is difference between P wave and S wave. See, now let us discuss some of the uh, ranges of earthquake. See, ranges of earthquake ranges and measurements. See, this is very much important with respect to the UPSC prelims. Ranges and measurements. See, ranges generally minor earthquake. See, we calculate earthquake in the magnitude, that is 3 to 3.9 is minor, 4 to 4.9 is light, 5 to 5.9 is moderate, 6 to 6.9 is strong, 7 to 7.9 is major earthquake, 8.0 more than 8 point is greater earthquake. So, and now the new term called megaquake. Let us discuss what is megaquake. So measurements of the earthquake. See, we can measure. See, there are multiple scale. Initially there were Richter scale and Mercalli scale, but now there are multiple scale has been introduced to measure the earthquake. That is Richter scale. Another First one is Richter scale, next one is momentum magnitude scale, and next is Mercalli intensity scale, body wave magnitude scale, surface wave magnitude, Shindo scale. This is Japan exclusively. This is introduced by Japan. See, UPSC can ask similarly. See, very easy question. Shindo scale recently seen in the news with respect to measurement of earthquake. See, earthquake is important theme of UPSC. You can expect a question with respect to this earthquake, this content. You will get a shortly you will get one question from this video. I am damn sure about that. So let us start with the Richter scale. What the Richter scale, the term the Richter scale measures is called as magnitude. So magnitude measures of magnitude of the earth, that is the total energy released during the event. The total energy. See, it is very much precise. It says that how much energy released during the earthquake, that is called Richter scale. So that measures the magnitude. The Richter scale is a logarithmic, meaning that is for each number it increases the scale. The earthquake magnitude increases by the factor of 10 in amplitude. Roughly 32 times more energy is released. See, this is not necessarily needed. So they are saying that they are measuring it is logarithmic measuring. The earthquake's magnitude increases by the factor of 10, the 30 times more energy is released. Richter scale is less accurate for the large earthquakes. Magnitude above 7.0, see, it is very much important. Richter scale is less accurate for the large earthquakes. If the earthquake is very large, so the energy released you can't measure in a correct way. Next, momentum magnitude scale. What is momentum magnitude scale? It is, see, when compared to Richter scale, the more accurate and modern way of measuring the magnitude. So the momentum magnitude scale, the name suggests magnitude, it is modern way. So, and it is more accurate when compared to Richter scale. So, and especially above 7.0. See, here the lacuna is 7.0. That lacuna is addressed by Richter scale as a lacuna of more. You it can't measure the earthquake more than 7.0. That lacuna is addressed by momentum magnitude scale. What, that lacuna is addressed by momentum magnitude scale. Okay, now, like Richter scale, it is a logarithmic, but considering more factors, including the fault length, fault slips, rock properties. It considers more criteria, provides more reliable measures on earthquake energy released, especially for large scale event. It is similar to Richter scale, but preferred for measuring very large earthquakes. See, it is similar to Richter scale, but measure probably it is preferred when the earthquake magnitude is very high. Next, Mercalli intensity scale. Here magnitude. Here the name says intensity. Measuring the intensity or effect of an earthquake at a specific location based on humans' perception, structural damage, and ground shaking. It literally says how much damage the earthquake has caused. That's all. That is called Mercalli intensity scale. The Mercalli scale is subjective and varied in the location. That means if the location has multiple buildings, location A has multiple buildings, location B has very less building, you can't depend upon the Mercalli scale, because here the earthquake happens means here more destruction will be created, here less destruction will be created. So you can't say the accuracy with respect to damage caused by the earthquake. Mostly you can depend upon magnitude. So the scale ranges from 1 to 12. The Mercalli scale is influenced by subjective reports and human perceptions, making it less precise than magnitude. So it is less precise than magnitude. Next, body wave magnitude. It measures the magnitude seismic waves that travel through Earth's interior body, such as P wave and S wave. Typically used for distance earthquake, where the body waves are first to arrive, can provide early data on earthquake size. So body wave magnitude scale. So it's very simple. Measure the magnitude of seismic waves, that is P wave and S wave. So typically used in distance earthquake. It is used in distance earthquake. Here the keyword is distance earthquake. Body wave, distance earthquake. Surface wave magnitude. Surface wave magnitude, measuring of the magnitude based on the surface wave. Here body wave, here surface wave, which seismic waves travel along the Earth's surface. Using mainly for the larger earthquakes. See, it is used mainly for the larger earthquake with surface effect, especially those are felt on the ground. Next, the important point is Shindo scale. This was made by Japan. So to measure the what intensity of the earthquake, ground shaking, like Mercalli scale. It is like Mercalli scale. It is used to measure intensity of the earthquake. Ranges from 1 to 7. 1 is not felt by people, slight shaking. 7 is severe damages. Now, Medvedev spawn here Karnik, that is MKS scale. MKS scale measures the earthquake intensity, focusing on the effects experienced on the Earth's surface. It is also measures the Earth's surface rather than energy release. See, here the UPSC will mainly focus on swapping the word with intensity and magnitude. You should focus what? MKV scale. MKV scale is measures intensity. Intensity. It helps to assess the degree of shaking felt by the people as well as damage to the building. So it is also 1 to 10. 1 is very weak, 10 is extreme. So if 8 comes means severe damage. Severe damage, MKS 9 means very severe damage. That is zone 5, like in India, zone 5. Now, it is one of the very much important topics. See, Richter scale. Richter scale is measures magnitude. Momentum magnitude scale measures magnitude. It is more accurate. Then Mercalli scale measures what? It is intensity. And body wave scale magnitude. Surface wave scale magnitude, Shindo scale intensity. See, Mercalli scale intensity, Shindo scale intensity. Mm, MKS scale measures intensity, and it measures intensity. That's all. See, UPSC will swap the word with intensity with what, magnitude. So be careful. Be careful with respect to intensity and magnitude. Now let us discuss some of the important points with respect to seismic zone. Seismic zone. What is a seismic zone? See, this discussion seems to be little bit raw and big, but I'm damn sure about it. You will get one solid question from this 30 minutes discussion. I'm damn sure about it. A seismic zone. What is a seismic zone? A seismic zone refers to the region classified based on its potential to experience the earthquake. Based on its potential to experience the earthquake. The classification is based on past seismic activity, tectonic features, and geological structures. The classification is based on past seismic activity, tectonic features, geological structure. Okay. Classification of seismic zone. See, what is the classification of seismic zone? See, who classifies the seismic zone? BIS, Bureau of Indian Standards. This is first PY. This is first important point. India is divided into 4 seismic zones. See, there is zone 2, zone 3, zone 4, zone 5. No zone 1. Zone 1 has been removed. See, there are 4 zones, but 2, 3, 4, 5. No one. That means zone 1 says no earthquake, zero possibility to earthquake. No area in India we can say that there has zero possibility to earthquake. We see zone 2 says low damage. At least activity among all zones. Minor seismic activity is recorded. Regional coverages. Parts of Punjab, Haryana, Rajasthan, and Central India. See, this is zone 2. Punjab, Haryana. See, Delhi is here, but Punjab, Haryana. See, it is a logic. Punjab, Haryana, Rajasthan. Delhi is here. It experienced a 4.0 magnitude of earthquake this year. But Punjab, Haryana, Rajasthan, and central part of the India does not have the it comes under zone 2. Goa, Kerala, Goa, parts of Karnataka, parts of Maharashtra, and Tamil Nadu comes under zone 2. Zone 3, moderate damage. Moderate. So parts of Maharashtra, Jharkhand, Odisha, Andhra Pradesh. So see, it's very much important. Zone 4 and zone 5. High probability of earthquakes. That is Delhi NCR. Delhi NCR comes under zone 4. Zone 4. So Delhi NCR, Jammu and Kashmir, Himachal Pradesh, that initial part of the Himalayan region, including Delhi NCR. Some areas of Haryana and West Bengal. So zone 5 is very high damage risk zone. So entire Northeast India, see, total ready, entire Northeast India, Assam, Arunachal Pradesh, Nagaland, Mizoram, Meghalaya, Tripura. So northern and western Jammu and Kashmir, northern and western Jammu and Kashmir. So and also some parts of north part of Bihar, Uttarakhand, Andaman Nicobar. See, Andaman Nicobar Island comes under zone 5. Andaman Nicobar Island comes under zone 5. See, these are not all important points with respect to prelims. Zone 1, Zone 2, Zone 3, Zone 4, Zone 5, Zone 5 areas. Just with the help of the map, you can easily identify this. Okay. Okay. So, major human activities are triggered seismicity. So, what are all the man-made things with respect to trigger the earthquake? Mining and groundwater extraction, dam impoundment, fluid injection and fracking, and urban, coastal, and infrastructure. See, more migration towards urban also will cause the earthquake. Now, now let us go with the important point with respect to world earthquake. So now, see how I started. I started with Delhi, and I got with the Kamchatka Peninsula. So sorry, we started with Delhi and measurements of earthquakes, and now we are moving to the world earthquake region. That is earthquake near Russia triggered tsunami. Earthquake near Russia triggered tsunami. In 2025, one of the strongest earthquake recorded in the history. That is 8.8 magnitude. 8.8 magnitude, Kamchatka Peninsula. Now, Kamchatka Peninsula, first of all, you must know the location where the Kamchatka Peninsula is. See, it is where it is. It is in the Pacific Ocean. Kamchatka Peninsula, it is in the Pacific Ocean. That is also Far East Russia. Far East Russia, it is near to the USA, near to the Japan, near to the Russia also. Earthquake with magnitude of 8.8. It is the strongest earthquake in the history of world, and also it generated tsunami. See, what are all the impacts of earthquake in sea? Generally, it will impact tsunami. So Kamchatka Peninsula experienced the tsunami waves. Tsunami also. It experienced the tsunami waves also. So offering affected including Hokkaido, Japan, see Hawaii, USA, and British Columbia, Canada. All these areas were impacted by this earthquake. Volcanic activities also triggered. See a volcano. See, earthquake triggers tsunami, volcano. So see, this is very much important. Kamchatka Peninsula is very much important for this year prelims. See, this year prelims. So it is one of the mega quake. See, one of the mega quake. See, more than eight Richter scale. It is mega quake. Okay. So now let us discuss some of the important point with respect to this this Kamchatka Peninsula earthquake. So see, mega quake. Literally, we can say this. It is mega quake. Okay. So see, role of tectonic activities. Tsunami is see, tsunami, continent oceanic plates convergence. Continent oceanic plates. Tsunami is the strongest linked to plate tectonics. So you all know this. So there is no need for describing this volcanic triggering activities in Russia due to post seismic activities because due to instability. So you know that what is tsunami also. It is a long wave, sea waves caused by sudden displacement of volume of water, typically undersea earthquake. Okay. Okay, so in India, Delhi fault belt also is a vulnerable to earthquake. In India, Aravalli Delhi fault also is vulnerable to earthquake. So mechanism of tsunami generation, everyone knows. So these are all things you can know, you already know, but some of the things is very important with respect to exam. I had discussed it. Okay, so Kamchatka Peninsula is one of the important peninsula. So you can expect the question from Kamchatka Peninsula. Okay, so so it is very much important. Thank you.